Welcome to Internet Quality Academy. The channel is for the civil engineer, quality control engineer, and the site engineer who are working in the construction field. In this channel, we are discussing about anything and everything about construction and the quality control. And today also, I'm going to discuss about a very important topic, that is the reinforcement. Reinforcement is the backbone of concrete, and concrete is the main pillar of any project right now. So we need to know in a better way about the reinforcement to serve the concrete or the structure in a better way. So today I'm going to discuss about the 10 points in a question and answer format to know our reinforcement in a better way. So stay tuned until the end to get the full information about the 10 most common questions or the 10 points about the reinforcement. And if you're new in my channel, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notification. So without wasting time, let's jump into the subjects. That is, first things, what are the types of reinforcement used in construction? So there are different types of reinforcement used. First things, the material wise, that is a mild steel, that is a HOSD bar, TMT bar, welded fabric bar, and this welded wire mesh. So there are different types of bar used according to the requirement and according to the design parameter set by the designer. We are using different types of reinforcement, and according to the position of the reinforcement is different. That is the main reinforcement and the distribution reinforcement. The main reinforcement is mainly taking all the tensile stress, whatever developed or generated inside the structure, and the distribution that hold the main reinforcement in a position to give the structural integrity. And other also these ties, the face bar, whatever, the depending upon the location and the position, we are common name them the different bar. So the different types of bar is that mild steel, TMT bar, HOSD bar, welded bar, fabric wire mesh, and the fabric. So these are the common types of reinforcement used in the construction. The next part in the thing is explain the importance of lap length in reinforcement. Now first understand what is lap length, what is lap, and why it is required. See, our market is available length of reinforcement is 12 meter. Now if my beam is 20 meter, what we need to do, we need to splice the bar in a position so that we can get that 12-meter bar. So now the splices has the criteria. What is the criteria to satisfy? That everywhere we cannot place the splicing or the lapping. Why? Where is the loading pattern? According to the loading pattern, we need to find out the non-splices zone or the splices zone. In the splices zone itself, only we can splices or the lap. In this order, I have made a detailed video to find out the lap zone in the column and beam. The link is there or in the description. Please check. You will find out the full information. But for here itself, we need to place the lap in the on the splices zone. And what is the lap length? It is depending upon the concrete grade, diameter of the steel, and the structural requirement of the loading pattern and everything, and the bond stress of the concrete. So according to that, we need to find out the lap length. But it is normally we are using the 50D. The D is the diameter of the bar. So if it is a 16 diameter, that is in 15 to 60, 800 to be the lap length will be. So one after another, that will be the lap length. So, and it is important that it is ensuring the smooth transfer of the load from one bar to another bar in order to get the structural integrity. The next point is what the factor affect the selection of reinforcement bar size. The several factors influencing the choice of the reinforcement bar size, including the structural design requirement, the load of the structural will bear the spacing between bars, and the characteristics of the concrete mix. That means mainly loading pattern. That means whatever the live load, dead load, wind load, seismic load, and what is the diameter of the bar, what is the concrete grade. According to that, according to the design parameter, according to the loading pattern, that the different types of bar is selected by the designer. And as a site engineer, we need to place the same bar whatever mentioned in the drawing as per the location. That will be ensuring. Why this point is important? Because if we are neglecting the placing of the rebar, that means we are neglecting the loading pattern and the design parameter. That is why you need to know that these are the factors affecting, that is calculating whenever we are selecting the bar size. That is why we cannot change the bar size. So these are the things. And the next part is discuss the significance of cover of reinforcement in concrete structure. Cover refers to the distance between the surface of the reinforcement and the outer surface of the concrete. So it is the distance between outer face of concrete and the diameter of the bar or the main river. Why this cover is required? Because if there is no cover, so whenever the concrete is exposed to the environment, there's the moisture, chloride ion, sulfate ion, and another harmful chemical ions will ingress inside the concrete and it will start reacting with the reinforcement and the corrosion will happen. So what is corrosion and what is the chemical reaction of corrosion? I have made a detailed video. The link is there or in the description. Please check and you will find every details about the corrosion and how to prevent the corrosion also. So in order to get tea to the corrosion free, that is why the cover is placed. Adequate cover ensuring the durability and longevity of the structure by preventing the steel for being exposed to the harmful agents, that is chloride, sulfate, etc. So it is protecting the concrete as well as the reinforcement. That is why the cover is very much important, but sometimes in the side we are neglecting the cover. It is very much harmful, and whenever you are working in the side, please maintain the cover in order to get the structural integrity or in order to make the concrete healthier. What are the common methods of reinforcement concrete structure? That is, one method is the traditional method, that is a pre-stressing and the post-tensioning. There are in traditional reinforcement, steel bar are placed within the concrete to enhance its tensile strength and ductility. Pre-stressing involved applying compressive force to the concrete before the loads are applied, while post-tensioning applies the force after the concrete has hardened. These methods are chosen based on the structural requirement, design constraint, and construction techniques. So the traditional method, there is no stress applied before or after the concrete, but the pre-stress or the post-tensioning, the stress is induced inside the concrete, that and it enhance the durability, enhance the structural stability, and it is applied as per the requirement and as per the design criteria that to be satisfied. So there are different types: the traditional reinforcement, pre-stressing, and post-tensioning. The next common factor or common question is that how do you ensure proper placement and alignment of reinforcement during construction? This is very much important because in the design it is mentioned the whatever the diameter of the bar, whatever the spacing of the bar. Now we need to place that bar at the side, and if we cannot place in the proper position, the structural integrity will be in the problem. So what proper placement and alignment of reinforcement are essential to ensure the structural integrity and performance of the concrete element. This achieved through careful planning, accurate detailing in the structure drawings, and adherence to the construction standard and specification. Site engineers supervise the installation process, ensuring that the rebars are placed at the correct location, spaced as per design requirement, and secured firmly in place using spacer and support. Regular inspection and quality control measures are also implemented to verify compliance with the approved drawings and standards. So these are the methods we need to plan in the drawing. We need to mark at the side, and we have to place, and we have to tie, we have to bind. That is the all things we need to take care whenever we are placing the reinforcement at the side. The next things what we need to know, that is explain the concept of bar bending schedule or the BBS in reinforcement detailing. Now without BBS it is impossible to place the bar at the side. Now what is BBS and how to calculate the BBS? I have made a detailed video in the here or in the description. Please check and you will get the full information of the BBS. But for here the BBS is the bar bending schedule. Now what is this? Now in this drawing it is mentioned that 12 torr at the rate of 100 center. It is mentioning here. Now, what will be the length of the bar? What will be the 90-degree bend of the bar? And what will be the total cutting length? What will be the number of the bar? Suppose in 1 meter, we have 12 bar into 100 center. That means in 1 meter, 11 number bar is to be placed. But if this information will not be available in the design drawing or the structural drawings. But at the side, we need to prepare the bar bending schedule. That is the detailing of the reinforcement. That is the number of bar, length of the bar, spacing of the bar, shape of the bar, diameter of the bar, location of the bar, everything to be in a place. That is called the bar bending schedule, and it is to be given to the bar bender, and they will cut and bend the bar according to the bar bending schedules. So the bar bending schedule is a document that provides detailed information about the reinforcement requirement of a concrete structure, including everything: bar dia, bar size, bar dimension, bar shape, bar location, cutting length, bend direction, everything. So without the BBS, it is impossible to make the reinforcement is it is in the place. So the first things we need to do the prepare the bar bending schedule as per the design drawing. So as a site engineer, you must know what is bar bending schedule, and according to the bar bending schedule, we will place the reinforcement. Then discuss the challenges associated with the corrosion of reinforcement concrete structure. See, we already discussed about the corrosion. Corrosion of reinforcement in concrete structure is a significant durability concern that can compromise the integrity and service life of the construction. It occurs when the steel bars are exposed to moisture, oxygen, chloride ions, and also the carbon dioxide. So to prevent the corrosion, we need to protect the concrete. We need to do the regular maintenance. We need to do the cathodic protection or something, corrosion resistant steel according to the requirement. So these are all the things that the best practice or the prevention of the corrosion we need to do. We need to make the proper cover. We need to make the impermeable concrete. We need to provide the lower water cement ratio, the proper mix design, proper placing of the concrete, compaction of the concrete, curing of the concrete. These are all the factors we have to deal in order to prevent the corrosion of the concrete. What is happening? The oxygen and chloride ions leading to the formation of rust and subsequent expansion, cracking, and spalling of the concrete cover. Corrosion can be accelerated by factors such as exposure to marine environment, deseising salt, carbonations, and poor construction practice. Preventive measure, including proper concrete cover that I already discussed. So these are the things we need to take care whenever we are dealing with the corrosion of the construction reinforcement, and it is hugely impacted on the structural stability. So if you are a site engineer, please very much be careful to prevent the corrosion of the concrete. The next part is how do you ensure quality of reinforcement during reinforcement procurement and construction. This is very much important because the designer has made the design, and according to the design they have given maybe FE 500 or FE 500D, and the spacing and everything is there. Now we need to purchase and we need to place the bar at the side. Now it is coming to the quality control. So how to ensure? Ensuring the quality of reinforcement involves rigorous inspection and testing procedure throughout the procurement and construction phases. That means we need to do the inspection, the physical inspection, verification, and the testing, the mechanical and the physical property. What is the mechanical properties? It is tensile strength, it is the 0.2% proof stress, or the ductility, what is the ductility, and then chemical and the bend test, rebend test. So everything we need to do test according to the requirement or according to the in India IS 1786. So in order to finalize that this bar is as per the design. Quality checks begins with verifying the compliances of reinforcement materials with relevant standard and specification before procurement. During construction, site engineers supervise the handling, storage, cutting, bending, and installation of rebars to ensure adherence to approved drawings, tolerance, and construction practice. That means we are taking material as per the requirement, we procure the material. Now if you are not stored the material proper way, then again the corrosion or the rust will come on the reinforcement, and again it will be harmful for the reinforcement structure. So these are the things we need to check in order to get the regular inspection, storage properly, cutting, bending properly, and regular test and the inspection. And whenever it is placing on the side, again we need to check the diameter, spacing, and everything whether it's in place or not. So in this way we can ensure that the quality of reinforcement during procurement and construction. The next is, sorry, this is not next is what are the factors to consider when designing reinforcement for seismic resistance structure? This is the designing part, but also as a site engineer, we need to know, because if we know that this is the seismic zone or the seismic earthquake prone zone, then we need to take care the special care whenever we are placing the concrete or placing the reinforcement at the site. Why? During reinforcement, Designing of reinforcement for seismic resistant structure requires careful consideration of several factors to enhance their ability of withstand seismic forces. These factors include the seismic zone and site-specific ground motions, characteristics, structural configuration, and geometry, material properties, detailing requirement, and ductility, and energy dissipation and connection details. So these are the things we need to take care when we are selecting the reinforcement in a seismic resistant structure. And as a site engineer, whatever mentioned in the drawing, we need to place and we need to follow without thinking anything. It's a brain in the freezer mode that we need to follow each and everything, whatever the designer or the structural engineer saying whenever we are dealing with the seismic zone. So these are the things, the common questions or common factors, what is about the reinforcement. So in this way, we can know our reinforcement in a better way and we can perform in a better way at the site to avoid any type of corrosion or any type of mishandling or anything in order to get our concrete structure durable and longer lives. And I hope you find this information as useful. And if you find it useful, kindly subscribe my channel and hit the bell icon so that whenever I upload a new video, you will get immediate notifications. And I'm waiting for your valuable comments so that from your comment, everybody will be benefited. And if you want to know anything about quality control and construction, please let me know. I will come with more content like this. Thank you once again for watching me.